Okay, so like I said, this part two of vertex form is key features of a quadratic function. So as we go through all of these vocab words on the left, I put in the definition for you. We're just going to do an example of each one, and what we're using for the example is this picture here. So we're using this graph, and this is the equation that goes with it. So this equation is this graph. So these are the same. So as we go through the examples, I'll talk about how you can tell what all of these things are by looking at the graph and also by looking at the equation. So the first thing that we're going to talk about is axis of symmetry. Also too, I want to note that some of these things you probably have learned about, like in Algebra 1 when you learned about quadratics, but we're still just going to go over them like you haven't seen it. So the axis of symmetry is an invisible vertical line that cuts the parabola in half. So if you look at this picture, we usually show the axis of symmetry with a dotted line. See this dotted line right here? Like if you can imagine folding this in half on that dotted line, all the points would match up. So all of these points would be reflected over and they would match up. So that's the axis of symmetry. How we notate the axis of symmetry, it's really, we want the equation of that line. So the equation of a vertical line is x equals whatever number it goes through. So this is going through 1 on the x-axis. So that means that this equation of this axis of symmetry would be x equals 1. So I'm going to write that over here. That's the example. So if you're looking at the graph, you just say x equals whatever it goes through. If you're using just the equation, like let's say I didn't give you this graph, and I only gave you the equation, the number that it goes through is actually whatever h is. Okay, so remember, this is h. So if I just gave you this, you would still just say x equals 1. And remember, it's the opposite sign here for h, so h is positive. So that's axis of symmetry. Vertex, we already learned about last time, but I'm still going to have you guys give me the vertex in this section. Remember, it's the turning point of the graph. It's hk, so if you're looking at this, h is 1, k is -4, so it's 1, -4. If you're given a graph, this is the vertex here, the turning point, so you just identify that ordered pair. So see how if I start at 0, 0, it's still 1, -4, and that's your vertex. So given a graph or given an equation, you can identify the vertex. X and Y intercepts, we're not really going to practice today, but I just wanted to mention it because they are key features of the graph. When we learn about graphing them, we'll talk more about x-intercepts and y-intercepts, but basically an x-intercept is where it hits the x-axis. So you can only get an x-intercept from the graph, so that's why we're not practicing them today. So this is one x-intercept, that's the other one. So this is the x-axis. So those are the 2 points where the graph hits the x-axis. So it's x equals, well, you don't even have to write that. You can just say -1 and 3. So -1, 3, those are the 2 x-intercepts. The y-intercept is the point where it hits so also actually on an x-intercept, there are usually 2 of them if you have a parabola because it goes on both sides. Every now and then you'll get one that doesn't have any x-intercepts or only has 1, and we'll talk more about that like when we get there. A y-intercept, there's typically only 1. And so if you look at this graph right here, here's the y-intercept, and it's at -3. Okay, the next thing we're going to talk about is whether the graph has a minimum or a maximum. So usually what I ask here is I'll say, does it have a minimum or a maximum, and where is the minimum maximum? So basically it always has a minimum if the graph opens up. So it's considered a low point. So this would be an example where there's a minimum because this is the lowest part of the graph. And then it keeps going on forever up, right? So anytime it opens up, it has a minimum. If you had something, so that's gonna look like this. If you had one that opened down like this, that would be considered a maximum because it's a high point of the graph. So that's when it opens down, opens up. Remember, to determine open up, open down, open up is when A is positive, right? So if you just had an equation, so looking up here to the equation, A is positive, it's +1 in the front. So if I just had this, I could still tell that it was opening up because of the negative, the no negative. Opens down is when A is negative, just so you remember. So that would be considered a maximum. So not only do we say that it has a minimum or maximum, we want to say where it's located. So to say like where it's located, we use the value of K. And so like this, for example, well, let me go up here. So K was -4, right? So we would say that this graph, this equation, has a minimum at -4. And so the reason why we're using -4 is, see how this is where the vertex is? So if you look over to the Y, the lowest Y value is -4. So that's why we would say it has a minimum at -4. This one's kind of tricky, minimum, maximum, but so that we would say min at Y equals -4. So that's how you would answer a minimum maximum question. You say minimum or maximum, and then where is that minimum or maximum? You use the K value. Domain and range are two things that you probably have learned about at some point. Domain is all of the X values that are on the graph. So you're looking at the graph from left to right. So let's go back up to the graph for a second. So I'm looking at from left to right. I want to know which X values are included on this graph. So the part that we can see looks like it goes from like about -2 to 3-ish. But see these arrows here? That means it's going on forever. So this graph is going to very slowly continue to go on forever and open up and open up and get wider and wider and wider, and it's never going to stop. So that means that every single X value is included on this graph. And so how we say that, how we describe that, is we say all real numbers. And so what that means is all real numbers are just like, not just whole numbers, it's all the numbers. So any fractions, decimals, positives, negatives, zero, it includes everything, because every X value will always be on one of these graphs. So when I ask for the domain, the answer is always all real numbers, just so you know. Okay, and then the range is all of the Y values. So this one is a little trickier. The range and the minimum maximum kind of go together. We answer them sort of similarly, and I'll show you why. So the range is the Y values. So if you look back at this graph, so we're looking at it up and down. So this one's not all real numbers because yes, it's going on forever up, but it's not going on forever down. So all these negatives below -4 are not part of the graph. So what we would say for the range is we would say that Y, for this one, it's Y is greater than or equal to -4. Because do you guys see how like everything on the graph is above -4? So if it's everything is above -4, we're going to say Y is greater than or equal to -4. So let's come back down here. And so anytime you have a minimum, it's going to be greater than or equal to. If you had a maximum, it would be less than or equal to. So that's why I said the minimum, maximum, and the range like sort of go together, because notice we use the same number when we're describing each one, and you can use whether it has a minimum or maximum to determine this symbol. And if you're not comfortable with like the greater than or less than symbol, you can just use words. You could say Y is greater than or equal to -4 rather. Okay, so that's just the gist of each one. I'm going to do some examples. So I'll probably skip around. I'm going to do like one equation one and then one graph one, and then go back into the other equation and graph. So just so you can see both. The practice that you're doing has a combination of equations and graphs. All right, so let's start with A. Before I start though, does anyone have a question about anything I've done so far? You can put it in the chat, or unmute is fine too. Everyone's good so far? Okay, so let's start. So identify the key features of this quadratic. So this time we just have the equation. So the vertex, remember, is HK. So this is H, this is K. Remember, you want the opposite sign, so H is 3. So the vertex here would be 3, 4. Most of you seem pretty good with identifying the vertex, which is great. All right, next is axis of symmetry. So remember back up here, if we only have an equation, axis of symmetry is just X equals H. And you do have to write X equals because it's an equation. So you can't just say, so down here, H is 3, right? You wouldn't want to just write 3. You have to write X equals 3 because that shows that it's an equation of a line. Okay, so now let's think about whether it has a minimum or a maximum. So to do that, you want to think about, does it open up or does it open down? What do you guys think about this one? Does it open up or open down? Remember, look at the sign in the front. Anyone know? You can put it in the chat or on mute. It's positive in the front. So what does that mean?
It opens up.
It opens up, whoever said that. Yes, very good. So it does open up. It would only open down if it's a negative in the front. So this is a positive in the front, so that means it opens up. So what I like to do is I like to just like sketch a little parabola that's opened up. So visually, it's helpful for me to determine like the range and the minimum or maximum. So now that I see, okay, it opens up, does this have a high point or does it have a low point? Do we see how this would be considered a low point? So that would mean that it has a minimum. And then we want to say, what number is that minimum located at? Remember, if you look back up here, for minimum maximum, you use the value of k to determine the location. So we would say that this has a minimum at 4. Or you could say y equals 4. Either one, it's fine. So it has a minimum at 4. Next is domain. Remember, domain is always going to be all real numbers because this is going on forever to the left and the right. So this is all real numbers. That's always your answer for domain in this section. And then the last one is range. So range, remember, we want to look at it from up and down. So that's why it's helpful to have this little sketch here. So we're looking at it top to bottom. And we want to think about, is y greater than some number or less than some number? So remember, anytime it has a minimum, it's going to be greater than. So picture like this is at -4. Is the graph above -4 or is it below -4? See how it's above? So we would say that y is greater than or equal to -4. So that's our first example. Do we have a question so far on that one?
No.
Nope, good, okay. So now I'm gonna skip to the last page and do one of the graph ones. So there's 4 examples total. So let's do this graph one. I personally think the graphs are a little bit easier because you have a visual, but I don't know, you guys can tell me what you think. So again, vertex, now we don't have an equation, so we can just look at the picture. That's the vertex. So we just have to identify that ordered pair. So if we're starting at the origin, remember to get an ordered pair, you're gonna go left and right first. So -2, and then up and down, down 2. So that's gonna be -2, -2 for the vertex. Axis of symmetry, so now that we know h, you could just not even look at the graph and say axis of symmetry is x equals -2, but just to show you on the graph, the axis of symmetry always goes through the vertex. So that would be the axis of symmetry, and so it's x equals whatever number it goes through, which is -2 or h. Okay, does this graph have a minimum or a maximum? What do you guys think? Does it have a low point or a high point?
A low point.
A low point, so it has a minimum. Good, so it has a minimum. Now we just have to figure out where is this minimum. So we use the y value of the vertex, or k. So we would say this has a minimum at -2. Okay, domain is, remember, all real numbers because we're looking at it from left to right. And then lastly, for the range, I know I need a y, and then now we have to determine, is it greater than or is it less than? So if this is our low point, -2, is the graph above it or below it? It's above it. So that means it's y is greater than or equal to -2. And that would be your range. So there's a graph example. Questions now?
No.
No? All right. So I'm just going to go back to the front, and then we're going to just do the last 2 examples, and then you guys can do your practice. So here's the second example on the front, the other equation one. For the vertex here, we have h, k. Just remember we want the opposite sign here for h. So h is really -4. So it's going to be -4, 5. Axis of symmetry, again. So like reference these notes as you're doing your practice. I put the filled in version on Classroom already. So if you didn't have a chance to write it down, just reference that. But it's x equals h, right? So this axis of symmetry, if my h is -4, is x equals -4. Okay, so now we have to think about if it has a minimum or a maximum. So remember, for minimum maximum, you want to think about, does it open up or does it open down? See how this one has a negative in the front? So that one would open down. And I like to just like sketch a little parabola that's opening down, just so visually I can kind of wrap my head around what all these are. So if it opens down, it would have a high point, right? So that's a maximum. For the number, remember we use k. Oops, I don't know if anyone noticed. I messed up. Does anyone see what I did wrong for the vertex? Anyone? What's k supposed to be?
-5.
-5. So if that happened, that kind of happens to me a lot. Sometimes I make like little mistakes like that. Good, guys. Just let me know because sometimes I don't realize it. So anyway, I just was prompted because I just saw that this was 5 and that was -5 and those are supposed to match. Anyway, so for your maximum at what point, you're using k. So this has a maximum at -5. So that means like if this was on the coordinate plane, this would be at -5 on the y axis. Okay, domain is going to be all real numbers, as always, and then range. So now let's think about the range. We have a y. We know y is either greater than or less than something. So since this is pointing down, and this is a high point, do we see how the graph is below that high point? So we would say that y is less than or equal to -5 because the graph is below it. So less than or equal to -5. So writing, like creating the little visual, I think is super helpful. And I'm a math teacher and I always have to draw that. Otherwise it's hard for me to picture in my head, like what it looks like. All right, so there's another equation example. How are we doing? Do we have a question about that one? We're gonna do one more. And then if anyone feels like you want some more, you can stay back and I'll go through some of the practice with you guys. Okay, so part D is another graph one. So let's do vertex. Here's the vertex. Maybe some of you guys can help me out here. What's the vertex here? Anyone want to share? What's that ordered pair? This is the origin. We go right one and down one. 1, -1. Good. Who is that keeps answering?
Me, Braden.
Braden? Okay. Thank you, Braden. And also in the chat, I know some of you girls are writing in the chat too. Thank you. All right, so 1, -1 is the vertex. Axis of symmetry. Someone want to do the axis of symmetry. So it's x equals, where does it go through? One. Very good, Emma. So x equals 1 would be your axis of symmetry. Remember, x equals h. Okay, does this have a minimum or a maximum? What do you guys think? Maximum. Excellent. So it's a maximum. Okay, where is this maximum located? You don't want to do that part. Remember, you're using the y value.
1.
So it would be -1 because this was negative, right? Remember, we want to use k. So it's a maximum at whatever k is. So you're using the y value. So you're looking here. So you're not using this value, you're using this. So it's a maximum at -1. Okay, how about domain? This is an easy one. Someone new want to answer that one? Domain, what's the domain, Ben, every single time? All real numbers. All right, thank you, Caroline. Okay, and then last one, range. I know I need a y, then we have to determine, is it greater than, is it less than? So let's look at the picture. If this is my maximum, -1, is the graph below it, less than, or is it above it, greater than? It's below, so it's going to be less than or equal to -1. Now, when you're doing them, remember that your number here for maximum or minimum should match your number here for the range. Okay, so there is our last example. What questions do we have? Anything?